and welcome to this Fusion 360 tutorial by Hubs. My name is David and today I'll be designing and optimizing a jet engine bracket for CNC machining in Fusion 360. I got the idea from a design challenge held by GrabCAD and General Electric, in which they challenged engineers to optimize a bracket. For this video, I closely recreated the bracket and added some design aspects that could make CNC machining more complex, that are very common and that I see quite often here at Hubs. Specifically, the use of thin walls and sharp corners. First, I'll explain why thin walls and sharp corners are problematic for manufacturing of this and any other design. Next, I'll remodel the whole bracket, paying extra attention to avoiding thin walls and sharp corners. So here we have the bracket and you can see what we mean by sharp corners looking at this area. The problem with sharp corners is that they are difficult to machine. This is due to the fact that the two most common CNC cutting tools, end mills and drills, are cylindrically shaped and have limited cutting length. That means that the geometry of the tool determines the radii on the part, and so the inside corners of the part will always have a radius. There are ways to make 90-degree corners in CNC machining by using undercuts and special tools as well as EDM. However, this requires more time and money in comparison to standard tooling. Next on the bracket, you can see here that these walls on the edges of the bracket are very thin. Decreasing the wall thickness reduces the stiffness of the material, which increases vibrations during machining and lowers the achievable accuracy. This might not be so problematic with metals, but especially plastics are more prone to warping and thermal softening, so a larger minimum wall thickness is required. Now that we've discussed why sharp corners and thin walls should be avoided, let's remodel the bracket. Alright, now I'll start recreating the model. I'll first start with the first sketch. And just starting out with a rectangular shape, then give it my dimensions, 95 and 180, which is very similar to the GE bracket. Then I'll extrude it to be 22.5 millimeters thick. Next, I'll be extruding the middle section. So I'm starting my sketch on my middle plane, just projecting this surface. So I have it in my sketch. In the beginning, I'm just kind of eyeballing my geometry. And then I'm actually placing a circle here. That needs to be the circle needs to be tangent with the lines. And then I'm just trimming off the tip. And next I will be dimensioning my sketch here. I'm gonna give this an angle of 155 degrees. Gonna give this an angle of 105 degrees. The circle is gonna have a diameter of 36 millimeters. This angle is gonna be 152 degrees, and then finally the distance from the bottom of the bracket to the center of the circle is gonna be 44.5 millimeters. That's pretty much it. That's my sketch on the middle plane, and now I'm gonna extrude the whole sketch symmetrically by 18 millimeters. All right, that's it. That's the base shape. Then I will be adding my cutoff here. And to do that, I will be sketching on this plane. First have a easy shape. and then later I will dimension them. Okay. This side will be 82.5 millimeters long. I hit it on the spot there. This side will be 22 millimeters long. And then for this cutoff, I will just have a distance of 5 millimeters to this side. I'm already choosing 5 millimeters there because I will be adding a 5 millimeter fillet later. All right, that's my cutout that I will be having there. Just extrude it just on one side all the way through, and it automatically goes to a cutting operation. All right, I will be just mirroring this feature on my mid plane to have the same cut on the other side. In this case, I think identical and adjust will give the same results, but for me, it's sure, I mean, it needs to be identical on the other side. All right. Next step, clean up the geometry a little bit. So I will be adding some fillets on the 4 corners and also on the back of the part. I will give all these area 15 millimeter fillet. All right, the same as I said before, those sides where I left some space, give it a 5 millimeter fillet. So then you can also see it's nice and aligned with the spacing that I gave there. I will be actually starting with cut in the middle here, but I will be sketching on this surface here, and I will also start with the center rectangle that I will be placing on the middle line, and one corner will be at the bottom of the part, and the others will be, I will be just projecting this surface and align the highest point of my rectangle with the highest point of the geometry there. The cutout will be, I will be making it 15 millimeters wide. It's still not fully defined. I will be defining the middle point of the rectangle with to be aligned with the vertically aligned with the middle point of the part, so the center axis of the part. That's pretty much it for this cutout. Very easy. Just select all the geometry that all the squares that I want to use as a cutout. Same here. Extrude all the way through. Flip the side. Automatically turns it into a cutting operation, and then just remove that material from the body. All right, next I will be doing the cutouts to reduce the weight on the part, and I'll be starting by creating a sketch on this plane. First thing I'll do, I will draw a straight line from here to here as my reference point. Then I will be, for all of this, I will give it a 5 millimeter offset. This one, sorry, I will doesn't want to. I will select the edges one by one. Have a 5 millimeter offset on the inside, so -5. And then I will be starting to draw my triangles to divide the spaces. The and have another 5mm offset from this surface, from these lines, 5mm. Alright, and I'll have another rectangular cutout here, which I will be having a 30mm distance from the outside edges on both sides. I will be just copying this value as a reference, so it would change if indeed I had to adjust. From the outside, also here, I leave 5mm spacing. Alright, that should be it. That should define my geometry for the cutouts. Let's see if I did it properly this time. All the way, extrude all the way, flip it around so it turns into a cutting operation, and then we have the cutouts. Alright, this time let's fix it. Let's give it some fillets. I think I will be giving it a 5mm fillet, so it should be easy to machine with the same tool. First I select all the edges. Oops. Give it a 5mm fillet. Hit enter. And that's it. Nicely shaped cutouts that are easy to machine. Then next I will be creating the hole to attach the main to the main bracket. I will be just creating a point, so a construction geometry at the center of a circular or of a circle. So I'll just be selecting this edge and it automatically creates a center point. And then I can just create a hole that I will be placing on this face. We'll be using this point as reference point, selecting that it will also extend through the whole geometry and have a diameter of 20 millimeters in this case for that hole. Goes all the way through. Done. I go one step back that I forgot. I will actually the cutouts that I made before, I will be also just mirroring them on the other side. To do that, I will select features. I will select the cutout feature as well as the fillet feature. As the mirror plane, I will use my middle plane and have identical cutouts. That's it. It's also on the other side. Then I will be creating a little sketch on this surface again to position my holes. I will be starting from the center point of this circle and go straight to the corner to be perpendicular with the radius. Do the same on the other side. That's it. That's my sketch actually. And then I will be placing a hole, multiple holes based on the sketch, and I will be selecting these 2 points. This time I will be selecting a counterbore hole, also going all the way through. The top diameter is 20. Have a counterbore depth of 15 millimeters, and then the bottom diameter is 10 millimeters. That's it. Leaving enough space to the edge of the part to not have face any issues with thin walls, so part should come out nice and clean. And then I go back in my forward in my history again, so I have that hole again. I actually go back again and do the same mirroring action with my counterbore holes that I just created. Select again the middle plane to mirror those holes, and that's pretty much it. Have the clean part. Should be easy to machine. Yeah. That's it for this video. I really hope you enjoyed it and were able to take something away from it. If you have any questions or comments, just drop them below and we'll get back to you. It would really help us a ton if you could like this video and subscribe to our channel, and see you in the next video.